was taught there. Okay, so I cannot, I will cover the major part, but not every aspect of trigonometry. That's a 3 units course for an entire semester. Okay, so trig review. So what is the most important things in trigonometry? Right? Some of our students came to me. I can only speak, from what I have experienced. Some students come to me with a unit circle with every point marked. That's great. That's pretty good. But that's not the core. What is the core? The core of the definition of trigonometry, and it can be summarized in 3 letters. One is A, the second is R, the third is D. ARD. Okay, so if you talk about the ABCs of trigonometry, the fundamentals of trigonometry is ARD. So I'm going to explain these 3 elements. Okay, the first one, okay, the reason is called A because it's related to angle. Okay, so it's about angle measurement. Angle, right? Angle measurement. Angle measurement. The second one is called a reference angle. The last one, not the least. Okay, last but not least, definition. These 3 elements is the essential of trigonometry. The essential of trigonometry. Let's talk about the first one. Okay, so first of all, what is trigonometry? Could I assume every one of you have learned some geometry? That's good to know. Okay, you have learned some geometry. When you learn geometry, you learn circles, triangles, and polygons and all of that stuff. In particular, triangle, especially right triangle, right? We have learned Pythagorean theorem, similar triangles, congruent triangles, and similar angles and parallel lines and all of that stuff, right? Take the right triangle, for example. Take the right triangle, for example, right? Trigonometry basically take those triangles, take those geometric shapes, especially triangle, and bring them into a rectangular system. Okay, for example, right? You will have a rectangular system. When you learn geometry, you don't need to do rectangular system, don't you? You don't need a rectangle. You don't need this system, right? When you learn geometry, you don't need this. But trigonometry basically take those geometric shape, especially triangles, and bring it into this rectangular system. So it's like a digitized geometry. Okay, I'm borrowing this modern word, digitize. Digitize. Okay. And then as a result, we have to set up some, rules. We need to have some ground rules. And the letter A is about the ground rule. It's how do you measure angles, right? For example, I'm going to draw a line. How do I measure the angle? Do you measure this way? Do you measure that way? Or do you measure, go around a few times. How do you measure the angles? So we need a point of reference or line of reference to measure angles. So this first rule, round rule, is absolutely important. Okay, so let me show you, let me explain to you what is the rule. Okay, so I'm going to clean this up. How do we measure any angle? Right? In trigonometry, we have a ground rule. The ground rule says, starting from origin, we're going to draw an array. This position, okay, so I'm going to make it thicker. This position is called a standard position. This is called standard position. Position, standard position. Every angle we address in trigonometry is measured from this position. Okay, every angle in trigonometry is measured from this position. So you will have 6 functions, 6 trig functions. All these 6 functions, you know, their input are angles. Every such angle is measured from the same position. Does that sound pretty good? It's standardized, right? Is that standardization? And this rule, once set up, every mathematician agrees in the whole wide world, whether you speak Spanish, Portuguese, Japanese, Korean, German, French, any language you speak, or you from Iran, like Farouz, right? Or you from India?
Yes, ma'am.
Everybody agrees to it. And every teacher teaches this way. So we talk about standardization. That's the standard position. However, with the standard position, right, I can measure my angles like this. I can also measure my angles like that. How do you tell the difference? Sometimes they may be the same size. And we have a way to tell. We have a way to tell. If you measure, okay, if you measure something from the standard position, I'm going to have to draw the standard position one more time, maybe, you know, 7 more times, 10 more times, no problem. Standard position. Every angle is measured from this position. If you measure from counterclockwise, this angle will be considered a positive angle. Counterclockwise is a positive angle. If you measure from the standard position clockwise, that's a negative angle. Okay? But every angle is measured from standard position. So that's A. Shall we write it down? Shall we write it down, that rule? Round rule. Did you write it down? So let me write it down for you. So you may take notes. Angle measurement. Every angle or angles, I would say an angle is measured from the standard position. We know what's the standard position, right? counterclockwise, if measured counterclockwise. Some of you may think, oh, I already know this. This is trivial. Yeah, sure, it's very trivial, of course. But the important thing is you have to constantly use it. Okay, you have to constantly use it, counterclockwise. Okay, if you say, oh, I haven't constantly used it, then you may not have learned the trick the right way. What's the consequence of not learning the trick the right way? You have to memorize a lot of stuff. Okay, my goal of teaching this is that so you don't have to memorize a whole lot of things. I have students coming from trigonometry to my class with one sheet of formula. When I was going over pre-calculus contents, he constantly referred to the formula sheet, and he couldn't find things he needs. That's not the right way to learn trigonometry. You are basically dependent on a piece of paper. What does any good is done to you? Your professor can totally say, hey, you cannot use a cheat sheet. Sorry, you're screwed. Okay, so I'm asking you to be patient with me, because at the beginning, the simplest thing has to be addressed clearly before we can build on it. Okay, so if measured counterclockwise, the angle is positive. Okay, if measured clockwise, the angle, did I have a typo there? The angle is negative. So that's A. So A is about angle measurement. You will find this same rule, actually, if you learn polar coordinates and stuff like that. We'll try to touch that if we can. Polar coordinates is also set up the similar way. Okay, so you will see that a lot of certain ground rules are set up that way. Okay, so the next one, reference angle. Reference angle is the bridge you need almost all the time. You need almost all the time. You may say, oh, I don't use it very much. And once again, if you didn't use it very much, you might have not learned it the right way, or you learn it in some way that you have to memorize a whole lot of things, right? So what is the reference angle? I pick up my trigonometry textbook. I want to make sure I don't miss any word. I don't want to miss any word. Okay, so reference angle is a very, very important concept. It's a very, very important concept. And I have it here. Okay. Okay. Reference angle. A reference angle is always relative to a measured angle. A reference angle is the positive acute angle between the terminal of an angle and x-axis. Okay, I'm writing this down, but I still haven't found the place in the textbook. I just want to double check. Do you guys agree? If you guys have learned this, do you agree with that? Did I miss anything? Because I don't want to miss anything. Did I miss anything, Farouz?
Between terminal side of an angle and x-axis, maybe just one word for students to know what's the terminal side of an angle.
I will explain. Yeah. A reference angle for any angle theta is a standard position. It's a positive acute angle. Yeah, I didn't miss anything. I'm going to explain to you. Okay. Are you guys ready? So what did you want to say, Farouz? And I think I cut you.
No, that's fine, Professor. I just as a tutor, I may explain more about the angle has three parts: vortex, initial side, and terminal side. Therefore, when you say terminal of an angle and the x-axis, terminal side was just a keyword to help the students to, catch up, visualize better. That's it.
Right. I'm certainly going to explain to you, right? So what it means, right? Suppose that we are measuring an angle, right? So we're measuring an angle. Okay. So when we measure the angle, what do? We have to we have to make sure we measure from the standard position, right? This is the standard position. So suppose I'm going to draw an angle, and this angle just end up here. So this line is called a terminal. Okay, this line is called terminal. So this angle, I'm going to call it A. Okay, in this case, can you guys repeat the definition? I'm sorry, I covered it. Sorry. Never mind. Let's do it over. I only just want to do it right. Okay, I want you guys to see the word, which is right here, as I'm drawing. Okay, as I'm drawing. Standard position is here. Okay, and I'm going to draw an angle. That's just arbitrarily, right? So this angle is going to terminate somewhere. So this angle, this is the angle I want. Okay, it has a terminal. It has terminal. Every angle has a terminal, right? And this angle, I'm going to call it A. Okay, this angle, I'm going to call it A. So the terminal, between the terminal and the x-axis, okay, between the terminal and x-axis, there are two angles. One is this guy. Of course, that overlap with A. And the other, with the x-axis, this is a green one. It could have another one, right? Right? These are two angles. You measure from x-axis to this to the terminal. You measure from x-axis to this terminal. But reference angle says a reference angle is the positive acute angle. So if you measure negatively, so if I'm measuring this way, that becomes negative angle, right? No, we don't want that. We have three angles here. Which one do you think is positive? Acute. So it has to be both positive and acute. So which one would that be? That will be this guy. And the other two cannot be called a reference angle. When this one is negative and this one is not acute, it's obtuse, right? So in this case, the reference angle happened to be the same as A. But we're going to give it a different name. We're going to give it a different name. We're going to call it theta. Reference angle, we're going to give a name. We call it theta. Okay. In this case, theta and A are the same. Now, Did you guys write it down? Reference angle theta and A happen to be the same when the terminal is in the first quadrant. Like I just measured here. Okay, I didn't go around. Okay, could I go around? Yes, I can go around. They're not always the same. Okay, for example, there's another case. There's another case. Okay, so I have this standard position, and I'm going to measure my angles from the standard position. As the rule says, I'm going to end up like this. And this is my angle, okay? And that's the terminal. Can I do that? Of course you can. And this is the terminal. So this terminal, okay, this angle, I go around, okay? Now, if this angle A, this is angle A, what is the reference angle? The reference angle is still the acute positive. Acute means less than 90 degrees, larger than 0, okay? Between 0 and 90 degrees. Do you guys understand that? That's acute angle. Not only it has to be acute, it has to be positive. So you cannot measure from the clockwise. You have to be measured from, you know, it has to be measured from x-axis to the terminal, and it's the acute one. Okay, so this is the reference angle. So if I call the reference angle theta, this time theta and A are different. You guys follow me? Yes? All right. Okay. So next, let's look at another scenario. Another scenario. And this other scenario, I'm going to measure the angle still from the standard position, but my terminal ended up here. That's my terminal. So my angle, of course, my angle is always measured from standard position. That's my A, but what will be the reference angle? The reference angle, read the words. The reference angle is the positive acute angle between terminal of an angle and x-axis. So here's the x-axis. Between the terminal and x-axis, there are two angles, right? What are these two angles? Between the terminal and x-axis, right? This is one angle, right? And there's another one. Which one will be qualified as positive acute angle? Obviously, it's going to be which one? It's going to be this one, not that one. You follow me? Both angles are between. Of course, you cannot measure negative either. You just have to just terminal between x-axis, less than 90 degrees, larger than 0. Okay, it has to be acute and a positive. Do you guys follow me? Okay, so this is the second case. So this will be the theta, right? If you call which one is theta, this is a theta. So the actual angle is A, its reference angle is theta. You follow me? Between the terminal and x-axis. And we don't consider negative angle at all. So if I ask you a question, is reference angle a positive angle? You say, of course, right? If I say, is reference angle an acute angle? They say, of course. But a reference angle has to be acute and positive between the terminal and the x-axis. Okay, so let's look at another scenario. The third scenario, okay, I'm going to measure from the standard position, of course. But this time, my measurements end up in the third quadrant. And this is my terminal. Now, I hope you have got the hang of it, but tell me, if this angle is A, right, this is still A, what will be the reference angle? What will be the reference angle for angle A? Where would it be? It should be this guy, right? It should be this piece. You follow me? Positive acute angle between terminal and x-axis. Does everybody get it? And reference angle is super duper important. Okay. Now, last case. Okay, so this time I'm going to measure still from the standard position. Okay, and this time I'm measuring my angle. You know what? I'm going to measure clockwise, right? Why not? I've always been doing counterclockwise. And this time I'm doing just clockwise. I ended up here. And my terminal is right here. What will be my reference angle? My reference angle is going to be this one. That's my reference angle theta. You guys follow me? So these are the 4 cases when you determine reference angle. Okay, if you had a trigonometry before, please review this part. Okay, and it's now 1:20. So tomorrow we're going to talk about definition. Okay, so we're going to talk about the rules, the 6 rules of trigonometry. Remember, we talked about function, right? Function is the theme. And function is a rule. Every function is a rule. Some of the rules are simpler. Number 1, 2, 3, 4, 5, 6, 7, 8, those are simpler rules. By the time we're doing exponential or logarithm, those rules get a little bit more complicated, right? You have to specify b has to be greater than 0, not equals to 1. So by the time we get to trigonometry, the rule needs some more explanation. We need to set the groundwork, the ground rule, before we can speak about the rule. So we have a platform. On that platform, we talk about the rule of trig function. That's all for today. I hope that will help everybody, whether you had a trig or not. Okay, but at least we reviewing these 3 elements. We just did 2. Okay, so we're going to continue to do this tomorrow, and I hope we'll have a good review. Trigonometry is a huge part of your success in calculus classes. It will run through Calc 1, Calc 2, Calc 3, linear algebra differential equation. You just cannot do these courses without dealing with trigonometry. All right. So without further ado, this has been a pretty long time. So I will see you guys. I'll see you guys tomorrow.
Thank you, Professor.
Yes, homework log 3 is in notes.
See you tomorrow.
Thank you for the lecture, Professor.
Of course. You're very welcome. I'll see you guys
Thank you,
tomorrow.
Professor.
Great job. You guys sustained this long. Give yourself a pat on the back. Very long lecture. I give you 2 breaks. I hope that helps. See you tomorrow. You'll be home.